Hey gang, today we're going to pick up where we left off with the last video. The last video, of course, I showed you how to set this 45-degree angle here on the leg and all the mechanical stuff involved, right? And then setting the servo to 90 degrees and reassembling it. Today we're going to look at calibrating the pulse width modulator card, and then we're going to set this wrist servo to the proper operations, or calibrating it, you might call it. So let's get started. First, we'll look at the highlights here with my pictures. I'm going to show you the end result of setting up the mechanical witness mark. So I needed an external battery power source, so I grabbed my 6-volt battery, and I needed my servo tester, and then I end up creating this mechanical witness mark right here. That's the goal in the first half of the video here. So let's see how I did that. I start out by telling you that the back servo card is the one we're working on. And of course, mine's pre-wired, got everything already wired in it. So these are my servo pins. And I'm working on the back right leg, so I'm going to be using pin 6. Even though his instructions tell you to use pin 0, I'm using pin 6. But you get the idea. Whatever servo you pick, if it's wired, pick the appropriate pin. If it's not, use pin 0. Doesn't matter. Okay, so do the leg setup. You can freeze frame this and read this. He's basically giving you an overview of how to set up the servos. Then to get into the actual setting of the mechanical witness mark, in these instructions, everywhere you see anything in square brackets, those are my notes. I added notes where I thought it might clarify Cyber One's instructions. You can use my notes, or you can skip over my notes and use Cyber One's. It gives you two perspectives. It's always better to have a couple of ways to look at something. So we're going to set up the pulse width modulator card and calibrate it. But before we can do that, we have to set up the mechanical witness mark using the servo tester. So get the camera up here where you can see what's going on. This is live, so you can see I have my battery. You can see I have my tester, and I've pulled my servo wire out, put an extender on it so that I'm talking to this servo right here at the wrist. His steps say set this to 1500, but before I just show it to you static, let me show you. See here, I'm actually in control of that servo. So I'm going to set that to 1500. That's awful close. There we go, 1500. That's midpoint on that servo. If you've got a cheaper servo tester, that's the 90 degree mark on most of them. So you set it at midpoint, and then we're going to get a felt tip. Is what I used, and I went in here and I put a dab right there like that and made a mechanical witness mark. That gives me the reference point that I need to work from, because I know I'm straight through the servo tester that there's no error being introduced. The pulse width modulator cards introduce the error. So I need to know this point before I use the pulse width modulator card. So I'm going to pause right now and hook this servo back up to my pulse width modulator card so that we can move on to the second part of this, how to adjust the pulse width modulator. Okay, I'm back. So I've got my servo hooked back up to my pulse width modulator card so that I can use it. So I need to start up the software. So I'm going to first make my COM connection using putty. And of course I got an error. All right, let me pause while I find out what this problem is. Okay, let's try this again. That's better. I got to log in now. Enter my password. All right, so now I'm talking to the Raspberry Pi. I have a COM link. And my problem there was I forgot to turn on the Raspberry Pi. So my mistake. Now let's get VNC set up. All right, so let me change my directory to MRL and whoops, start my robot lab .sh. Of course, if you're doing this on Windows, you'll use your bat file. I'm going to pause for a second. Okay, now normally I would start the browser on my desktop and not on the Raspberry Pi. But using the video software here, I get a conflict. So I'm running the browser on the Raspberry Pi, but you can run it from either place to do this. It's not critical. Drop my camera down out of the way for a second. I'm going to hide myself. It says start up the MRL without using the Spot Micro program. What that means is just the default settings. So I can tell that by coming to runtime. You see I have no services listed down the left-hand column. Auto start was turned off. So when it powered up, it just started MRL, my robot lab. It did nothing but start the software. Then he says create a Raspberry Pi service. He uses the name Raspberry Pi, so I am too. So I have a Raspberry Pi service now. Doesn't look like much right now, but hang on. Then he says you got to start a service, pulse width modulator service. and he calls his PCA, and that's an Ada fruit servo driver. And we'll start that. And he says go here. He tells you to use bus 0. Bus 1 is the default, so I'm staying on bus 1. The default address is hex 40. In my configuration, hex 40 is the address I have on that card. So I'm going to pick the Raspberry Pi as my controller and attach it. Now when I go to my Raspberry Pi, hey, things look a lot better. I have something hooked to it. Right? And here you can see on bus 1, I have a device at address 40, which is the card I'm going to be using. The rest of those addresses are because I have all my other components wired in. You may or may not have them at this point. Now scroll down the page. And he says start a servo service. Let's go back to runtime. He didn't really call out a name, so I created one called My Servo. That's a servo service. We'll start it up. And we'll go to My Servo. And I pointed out to you earlier that I'm actually on pin 6 of this pulse width modulator card. Even though he says pin 0, pick the appropriate one for what you need. And then I'm going to attach it to the PCA controller. Attach. So now I have a service. Pardon me. So if I go to basics, I'm going to turn on the limits here. Just so you can see, everything's a default setting. Min and max input and output are at their defaults of 0 and 180, and center point or midpoint is 90 degrees. And nothing is inverted, so everything's default. He says set your servo to 90 degrees. Well, mine's already sitting there, so I'm going to bounce off of it. Let me open the camera back up here. I'm going to bounce off of it. And then since I need to go to the 90 point, and rest is by default the 90 point or mid-range, I'm just going to hit the rest button. Bingo. And I'm going to go to it. Now the secret here is I've got to look at this mechanical witness mark and see if everything's aligned. And it's not. It's going to be a little bit hard to see. Let me see if I can just move that around there. You can see those points there. See that my mechanical witness marks are not aligned. Drop the camera out of the way for a second. He says, if all went well, everything will line up. If everything went well, both those points would line up, right? Your mechanical witness marks would be aligned with each other. If not, we need to adjust it. So the way you do that is you go to Python. You start a new program. Call it My Program. And you're going to enter a one-line program. And you're going to say PCA.set. Now remember, PCA is the name of the service that you started to control that pulse width modulator card. So you want to talk to that device. So you call it PCA. And then you want to run a function within it. So you're going to run .set. Set pulse width modulator frequency to 1.54. Oops. Not my mistake. 1.54. And I make a note there that pin 1 says you're going to use the output on pin 1. But it doesn't matter. When you set this card up, all 16 channels are going to get set to the same frequency. So it doesn't matter. You just use one and let it go. Servos usually run at 60 hertz. But since we're not aligned, we're going to adjust that frequency to make it come into alignment, to agree with our little test unit. So I'm going to set it to 54, and then I'm going to execute that code. And what did I do wrong? PC is not defined. I forgot to capitalize it. Okay. Let's try that again. Let's get rid of those errors. All right, didn't get any errors that time. Now nothing else happened. We just sent a command to the card that said adjust the frequency. So now we're going to go back to the My Servo. We're going to move it off of the 90 point. Let me get the camera back up. I moved off the 90 point, the center point. Now I'm going to go to rest. You saw the arm move. Now, the secret is to look at this mechanical witness part again. Mine, I could have left it there at 54, which happens to be the same as his, but it wasn't quite where I wanted it to be to my eye. So I'm going to go back to Python, and I'm going to change that to a 55. And I'm going to execute that code again. I'll go back to My Servo Lab. I'm going to move it off the center point again. See the leg moving? And I'm going to go to rest. Boom, and it comes back. Now I like my alignment. My alignment there looks real good. So I've calibrated my card so that when I'm using the software to go to the 90-degree center point, I'm actually going to the servo 90-degree center point. And I've eliminated the error introduced by the pulse width modulator card. All that said, that's what's being spelled out here. Okay, we walked all the way down through here to the points where it says, hey, if it's not there, decrement it from 54 to 53, or increment it up to 54 to 55, whatever you need to get to those mechanical witness marks. The next thing I did, I put a note in here. Note, I need to change that note too. Write down the final number you end up with. You will need it for spot later. It will be used as part of your regular spot code. That's the whole idea. We need to find this out so that we can put this calibration number into the software so that when we run this automatically, that servo card gets calibrated before anything gets moved. That's the whole idea. I hope that helps you to see that. Now what we're going to do, I'm going to shut down here for a second. I should say pause for a minute, and I'm going to hook everything back up. Actually, I have it all hooked back up, don't I? Yeah. I don't need the pause. We can just move on from here. Good. So the next thing we're going to do is we're going to talk about aligning the wrist. And what we want to do is get this wrist straight up and down and at the 90-degree mark. So let's look at some pictures again. I'll show you how I did that. Now, I'm going to walk through how I did this, but I'm not going to do it with any kind of precision. It requires too much time, too much dull time, dead time in this video. So I took some still pictures when I was doing it to give you some more of the accuracy. I'll walk through the steps so you can see them, but just know the bubbles are going to be better than what you're seeing. The bubbles will be more precise. So the first thing I did was I set the robot stand on a piece of glass, and I leveled that glass using a torpedo level. I leveled it, of course, both directions, and to get it leveled, I just needed the tiniest bit to bring my bubbles in. So I put something under that corner of the glass to raise it up. It was close enough for me. Once I did that, then I kind of checked that my dog was sitting level in the stand, because it's easy to put that robot in that stand and get it all cocked and crooked. So the bubble's not perfect here, but I just set it on there so you could see the process that I used. And of course, then I turned it 90 degrees and I made sure that I was level across the shoulders, that the body was level across the shoulders. Don't worry about the shoulder sag here. I'm using the body as my reference. Once I did that, then I dropped the arm, which is this section right here, and this servo. I dropped the arm down until it was perpendicular or vertical, whichever way you want to look at it. Perpendicular to the top of the robot or the glass, or vertical, using my torpedo level. And the torpedo level, of course, has this upper bubble that I used to make that adjustment. So once I got that vertical, then I used my steel rule. And since that's pretty precision made, I could set this down on the glass, and I had a 90-degree reference up that edge. I used as my reference points the center point of that servo. And I use the center point of that hole. Now it's off a little bit here so you can see the hole. And I use the center point to center point as my alignment. Then later in the steps, we're going to have to bring that wrist up to where it's parallel to the plate, or at 90 degrees to that vertical plane that we just created. Again, I used my torpedo level to do this. Nothing's level here. This is a slight arch and everything's, there's nothing flat really. So what I used as my reference, again, I used the center point of the servo and the center point of this hole. And I brought that level up against there until I got my bubble where I wanted it. Again, it's dropped down so you can see everything. That was the overall goal. Now, when I come in here and I'm going to move things around with the software so you can see the steps that were involved. I'm not going to go through all this with the levels. It's far too much manipulation and holding things to really capture well. That's why I used the still photos to augment this with. So you can kind of see with two views. Right? This is the precision way I did it was with the bubbles. And of course I drove it with the software. So let's see how to drive that thing around and get this all accomplished. We have to do this for all four wrists. Keep that in mind. I'm only going to demonstrate it with one. Okay, he tells you how he used the laser. I told you how I used my torpedo, and I kind of write what I just talked you through. And he opens the front right wrist. I'm not going to use the front right wrist. I'm going to use the back right wrist. So I'm going to have a different number, servo number, than what he uses in his example. So I'm going to not try to walk you through all this text. You can freeze it up, and read that. I'll give you there you got a nice frame you can freeze and read all that. But what he's basically going to tell us now is to come back to our software, and this time we're going to use the actual spot software. But before we do that, we want to eliminate all these. So my servo stops and releases the servo, this red X. So I'm going to get rid of that. This PCA, I'm going to get rid of it. This Raspberry Pi, I'm going to get rid of it. So basically, I'm right back to having started it up with all default settings, with nothing running. The difference being this time, I'm going to go down here and pick the spot configuration, which comes from Cyber 1. You can, if you want to, you can refer to these as the default settings. These are the settings that he's going to give you that worked well in his dog. They didn't work well in mine. They probably won't in yours. So I'm going to select that configuration and I'm going to start it. As soon as I do, things are going to start happening here. I'm going to pause the program while all this gets loaded. Okay, that didn't take long, but I elected to pause it just in case something went wrong. But it all fired up just fine. So now I have a spot loaded up. And I got a Raspberry Pi and I've got all the servos in there. Pardon me. Now before I do anything else, I have to go to Python and I have to run this code again. But there's a difference. I want the same values, but I want a different name for the service. Remember, PCA was the name we used in our little test setup. But I'm actually running the spot services now, and they're named differently. And so I have a front pulse width modulator card, and I have a back pulse width modulator card. And remember, it's the back card that has all the servos on it. So I need to change this to say back. Then I need to execute that card. And what have I done? I've just set that pulse width modulator card up to work with the new calibration point, the one we just did manually. Right? So now it's in there, it's ready to go. And I'm going to be working with the back right wrist. So I'm going to come to the servo drive. He says turn track on. I don't see where it seems to make much difference. I'm going to turn the limits on. Make sure I'm on a controller. Back, pin 6. Everything looks good. Now let me back up to the page here a little bit, kind of catch up with where we're at. All right. Open the wrist, which we just did. Turn track limits on. Set the wrist to the 180 degree position. So now, let me bring the camera up. Get rid of me. And bring the camera up. And I'm going to set it to the 180 degree position. All right, you can see there it says 180. But look where my leg is. See, here's vertical. My leg is not vertical. So he says, right, the foot should now be directly down. If it is not quite there, use the min output slider to adjust it so that it is. So here's output slider. Here's the min. I'm going to adjust this. I'm going to raise it up to about 50. Why? Because I've actually done this. And I'm move my slider down, move it back to 180. See how that brought that down and in line? Now, like I said, I'm not trying to show you here with the ruler and all that. You saw the stills. But that's how you're going to do that. You're going to move that until you get that lined up. So that part's done. Then he tells you, now set the servo to the 90 degree position. So I've moved the slider to 90 degrees. And you can see it's not parallel here. It's not 90 degrees. So he says, To adjust that, use the max out. It's just pointed out here. The foot should be level with the wrist joint. If not, use the max output level to adjust it so that it sits parallel. So I'm going to use my max and drop it down here a little bit, move it off 90, move it back to 90. You see I got closer, but I went too far, didn't I? So I'll move that back up again, off, and back to 90. There you see I'm pretty close, huh? Getting closer. And I would be, of course, putting my level up there to get the center line of that bearing and the center line of that hole is what I've been using until it showed level. Now, when I first did this, I had trouble here getting this max setting. I couldn't get this 90 degree to happen. And so what I did was I played with this minimum input and I slid it around a little bit until it started working. So I was real happy with that when I found that out. So the idea is to play basically with your min and max, but if you don't seem to be able to get it within range, then try playing a little bit with that minimum input. See if you can adjust it. Of course, once I've done that, then you have to go back and you have to check that 180 setting again, right? Yeah, still there. Still looks pretty good. And come back. And the 90 looks good. That's what we're trying to accomplish, guys. We got to do that for all four legs. He points out here, don't forget, I put in here, remember to save your servo configurations once you've done all this. Because he doesn't mention that. I just pointed out to state the obvious. But make sure you save all your work. And he says, remember that the front right and the back right servos are inverted. Those are the ones I've been working on, right? I was working on the back right. You can see here on the control, it's inverted. So with it inverted, he had me use the min for the 180, and he had me use the max to set that 90 point. But he points out, when you go to the left side, those servos are not inverted. So let's look here at the back left wrist. See, the inversion is turned off. So he says, when you're doing the left side, remember, you're going to have to reverse the max and the min use. That's simple enough. So that really wraps up with everything we're trying to get accomplished here. I just wanted you to maybe see the movements, see the software in use. Again, like I said, I didn't try for the accuracy that you want to get. I didn't try using the level and all that. You understand that principle. I just used the controls and let you see things move to give you a confidence level, to help you understand where all this is moving to. All right, so let's shut this down. I'll go in here and I'll do all my calibrations and I'll save all my set points. And I also remind you in my notes there, probably a good idea to take that spot configuration once you've done this and make a backup copy of it, you know, and call it, like my dog's name is Charlie. I might use a configuration called Charlie and put all my configurations in there. That way, when and if I do an update based on CyberOne's files, if by chance I bring his configuration in and overwrite spot, I'm not overwriting all the work I've just done. And I'm still in, I can still get my configurations out of my backup file and I don't have to redo all this work. That's probably the best way I can sum all this up. Just make sure you save your work. All right, guys, we'll catch you next time around. Have a good day.